All right, ladies and gentlemen, we are going to go over the 10.4 or the trig ratios. We're looking at this up here, which is your sine. Your sine is your opposite over adjacent, opposite over hypotenuse, which is going to be your SO. When you hear the SOHCAHTOA, and then ka is going to be your cosine, which is going to be your opposite over adjacent, and then your tangent, which is going to be your TOA, which is going to be your opposite over adjacent. Now, if you're looking at a right triangle, and this is just any general right triangle, we'll make one over here. For any general right triangle, you'll have, actually, let's make a better representation of that so that you can see a long side, short side type thing. So there we go. There's our right triangle. Now looking at this is going to be our A, our B, and our hypotenuse is always C. So if we're talking about your angle theta is always going to be one of these outside angles. So if I'm talking about, and this is going to be angle A because it's opposite the short side. Angle B is over here because it's opposite the B side, and angle C is always opposite your hypotenuse. Notice we're using capital and lowercase letters. The capital letters are the angle measurements, and the lowercase letters are going to be your side lengths. So if I'm talking about angle A, so if I'm looking for sine of A, it would be my opposite over here over my hypotenuse. So my A over my C, and that's where they get this from. So if we're talking about cosine, we're talking about your if we're talking about cosine, we are talking about we're going to say cosine of B. So actually, we'll still use A. So cosine of A means I want the adjacent, so the neighbor of A, which is side B, over my hypotenuse, which is still my C. If we're talking about the tangent, well, I don't need to really do much for tangent. I don't need to know my hypotenuse. I just need to know my opposite side, which is this one, and my adjacent side, which is this one, because it's the opposite over the adjacent. So tangent of A is equal to my opposite. Actually, let's change colors. Hold on. Change it to green so it'll stay color coded for you guys. So tangent of A is equal to A over the B. And that's how we got the A here over the B. So your opposite side is A, is little a, and your adjacent side is little b. Adjacent can never be the hypotenuse. It always has to be an A or B side. Hypotenuse is a hypotenuse till forever. Okay, so now let's look at the next part. So now we're going to look at how these general angles and trig ratios play out. So we're looking at our general trig ratios. So x, y is a big thing in this case because it's your point. That's the point here on your circle. And so then we're looking at x's and y's. So if it goes out, how far it goes out is x, and how far it goes up is, so this is your x, and that's your y. Okay, so if we're talking about except from the origin, so your hypotenuse plays something different this time. So your hypotenuse here can be found by using this equation, which is r is equal to, and it's just a form of the Pythagorean theorem. They just switch the a's and the b's out for x's and y's because we're dealing on a coordinate plane. Okay, and that's just going to be the distance from the origin to that point on the circle there. Okay, so now let's talk about your quadrants. So let's label up our quadrants. So in this case, let's use this blue here. So this is my quadrant 1, which means both of my points are going to be positive over here. This is my quadrant 2 because we go counterclockwise, which means my x will be negative, but my y will be positive. If we're talking about quadrant 3 down here, both values are going to be negative. And if we're talking about quadrant 4, we're going to have a positive x and a negative y. Your theta angle is always going to be, and we'll change colors right quick so we can identify our theta angle. Okay, so our theta angle is always going to be this one here in the middle, starting with the origin. That's your theta angle. So then from this triangle, if we're identifying our sine of theta, then it's going to be the opposite over the hypotenuse. Let's do opposite and the hypotenuse. There we go. I was trying to make sure you can still see the R. All right, so then we're going to look at cosine of theta. That's going to be the adjacent, which is this x side over here, over the hypotenuse, which is your R. And then for tangent, it's just y over x. Your R is equal to the radius of your circle. Okay, so these are the things you need to know about this setup. So now they're going to give us a point, and they want us to do this with it. So let's take a look. Make sure that you account for your quadrant so that you have the appropriate signs. We always consider our quadrant when we are graphing this stuff or looking at what sign our points are, if they're just giving us points, how it plays out. Okay, so we're going to look at this one. They give us this point, and then they want us to find, we're looking at, from our terminal side, we want angle theta, and they want us to find the trig ratios. Whenever they say find the trig ratios, it always means sine, cosine, and tangent. So they just want you to write up the ratios. So a couple things we have to do first. First, we have to create the situation in which we can find them. So we need to give ourselves an xy axis. Since this is negative, so I have a positive and I have a negative, which means I'm in quadrant 4. That's important to me because that knows which direction I draw my triangle in from my origin here. So I have to go over, because my 5, this is my x and that's my y. So that means I have to go over 5 and down 12. I'm going to connect my last side up here to my origin. Ooh, that's a horrible connection. Let's try that again. All right, there we go. We'll fake like it's straight. That's my radius. There's my right angle. And my angle theta, they said, is from the terminal side, which is this one over here. Terminal side is going to be here. Okay. So we're looking at an angle theta of here. Okay. So we need to find our R because we don't know it yet. So we're going to use the formula that they gave us for R. So we're going to say R is equal to the square root of x squared plus y squared. Okay, so equals, well, my x is 5 squared plus my y, which is, oh shoot, my y was negative. Negative 12 squared. keep my radical symbol. I haven't done anything to it yet. So that's going to give me 5 squared is going to be 25 plus 144 squared, 144 squared. 144 comes from the negative 12 squared. And then I'm going to take is equal to, well, 25 plus 144 is going to give me the square root of 169. That is a perfect square. So my R is going to equal 13. Now I know my R. Now I can go to work and finding my sine, cosine, and tangent. So let's find them out. So sine of theta. So from my sine from here, I'm going to go opposite over hypotenuse, so negative 12 over 13. Then I'm going to go cosine of theta, which is going to be equal to my adjacent. I'm going to turn that corner, look at my neighbor, over my hypotenuse. Then for my tangent of theta, I want my opposite over my adjacent, negative 12 over 5. Now I'm done because that's what they asked me for. Those are the values they asked me for. Now I'm done. Keep in mind, if you don't know your R, you're going to need to use this formula to find it. And you want to make sure that you draw your triangle in the correct quadrant based on the signs of the point that they give you. Okay, let's look at the next one. So they're going to give us negative 3 and a positive 7. So if we're looking at a negative 3, and a positive 7, so negative, positive, that means that I am in quadrant 2. So when I draw up my X and Y axis to find where I'm drawing my triangle, I'm going to end up over here in quadrant 2. All right, so let's look at quadrant 2. I need to go back 3. So negative 3. The actual measurement doesn't really make a difference. I'm not on a coordinate plane, so it doesn't matter. And then I'm going to go up 7. And then I'm going to connect back to my origin. There. That's going to be my R. So in order to find my R, because I'm going to need it, because we're looking at this for my angle theta. So if I need sine, I'm going to need it. If I'm going to do cosine, I'm going to need it. So let's go ahead and find our R. So R is equal to, and the formula you're going to want to remember is the square root of x squared plus y squared. In this case, y x. Okay, so now I'm going to write it up. It is equal to the square root of negative 3 squared plus 7 squared. It's going to give me the square root of 9 plus 49, which is going to leave me with 9 plus 49, which is 58. Is 58 a perfect square is what you want to ask yourself. If not, can I simplify it? And what does it simplify to? In that case, so I want to make sure that I am taking into account what it simplifies to, because it is definitely not a perfect square. So I want the factors of my 58. Oops. And so what I'm going to do is I'm going to use my graphing calculator. Okay, I'm going to go to my y equals screen, and I'm going to say 58 divided by x, and then I'm going to hit second and table because I want to know what the factors are. So if I'm looking at the factors, well, I have 1 and 58, which we know, so 2 and 29. Keep coming down. So this just gives me my factors. Well, what if I want to know if it's a perfect square? So then I can go back to my y equals, and then I can clear it out, and I can say 58 divided by x squared, and then it will give me if it can simplify the square root. So I'm going to go second table, and then if I notice, I'm going to click up. I don't have any ones that are going to work because all of these are in my y column. All of these are decimals except for 58, which means that there's no way to simplify the square root. So since I can't simplify my square root, I'm going to go ahead and just leave it as a square root of 58, which means I'm going to have to use that in my sine cosine, which means I'm going to have to rationalize my denominator. So I'm going to say r is equal to the square root of 58. So now when I'm looking for my sine, cosine, and tangent, so sine of theta is equal to opposite, meaning my 7, over my hypotenuse, which is the square root of 58. If I'm looking for, now you can simplify your square root by saying, not simplify it, rationalize your denominator by saying square root of 58, square root of 58 is going to be equal to 7 square root of 58 over 58. Because if I have two of them, it's just the 58 because it's 58 squared and I could just pull 58 out. So that's what I'm looking for. So then my cosine of theta will be equal to my adjacent, so my neighbor here, so my -3 over my hypotenuse, which is going to be my 58, my square root of 58. If I, in my head, rationalize my denominator, so I'm going to rationalize it times square root of 58 times square root of 58. What I'm left with is -3 square root, whoa, gonna run out of space. So I'm going to end up with -3 square root of 58 over 58. That's going to be my cosine theta. Okay, now I need my tangent, which is just going to be, it's not use screen, we use screen already. So my tangent of theta, actually let's move it because I don't want it to run into that. So tangent of theta is equal to my opposite over my adjacent. So my tangent is going to be 7 over -3. Now I have my, I'll use yellow, my sine of theta, my cosine of theta, and my tangent of theta. Okay, now we're on the last one. So we're going to do this one. So looking at my quadrants for this one, I have a negative and a positive, which means I'm going to be still in quadrant 2. So being that I'm in quadrant 2, those are my XY axes. I'm going to draw my line out here and my line down. This is going to be -4 this time, and this is going to be the square root of 7. Now I'm going to find my r. So r is equal to the square root of x squared plus y squared, which means I'm going to equal the square root of -4 squared plus square root of 7 squared. I know you're thinking, oh my God, this is so complicated. What do I do? No, anything squared. So the square root and the square cancel each other out. So I'm left with -4 squared is 16. So 16 plus 7. So 16 plus 7 is going to be, Lord have mercy. La, la, la. Okay, it's going to be my 23. So I have the square root of 23. That is not going to simplify. So now I have r is equal to the square root of 23. So now I can do my sine, cosine, and tangent. So let's do sine of theta is equal to, and we know that our theta angle is right here. So it's going to be opposite over hypotenuse. So the square root of 7 over the square root of 23. Okay, that means I have to rationalize my denominator, so multiply the top and the bottom by the square root of 23, which is going to leave me with 7 times 23 is 161. So I have the square root of 161 over 23. You can check to see if the square root of 161 is going to be something that you can simplify. So you just go back to your calculator, you go back to the y equals screen, you clear it out. 161 divided by x squared, second graph. And then we're looking at our table again. There's the 161. So that's underneath the square root. That's outside the square root. So looking underneath the square root, we don't have any whole numbers. So since we don't have any whole numbers, then that is not a perfect square and it cannot be simplified. So we're going to leave it as is. So we're going to leave that as the square root of 161. So now we're going to look at cosine of theta. And that's going to be adjacent, so my neighbor over here. So my -4 over the square root of 23. So I'm going to have to rationalize that denominator again. So square root of 23, square root of 23. That's going to leave me with -4 times the square root of 23 all over 23. And then I'm going to do my tangent. And I don't want to use that green because I just used it. Let's use this orange color. So then my tangent of theta is going to be my opposite over my adjacent. And so opposite square root of 7 over my adjacent -4. So now I have all of mine that they asked me for. I have my sine of theta, I have my cosine of theta, and I have my tangent of theta. So that about wraps it up. We are done with 10.4. The next video should be Mr. Cook with 10.5. Alrighty, we're done.